So welcome to the first chapter in our Big Data Analytics course. We've been looking at business intelligence systems in the previous lectures, but we would have to look at the Big Data Analytics course separately. Although we have so many similarities in terms of concepts and the dimensions of business decision making. So this lecture would look at business analytics, BI or business intelligence, big data, and data mining. We would look at each and the way they are unique and try to discuss the differences between these concepts. So what are the learning objectives? Upon successful completion of this chapter, you will be able to 1. Explain the difference between BI, analytics, data math, and big data. Define the characteristics of data for good decision making. Describe what data mining is. Explain market basket and cluster analysis. Okay, so as I mentioned, we would want to look at the differences. We looked at the business intelligence framework previously, and we identified several components, but these components are interrelated, and to avoid the mixing up of these concepts, we would have to just try to differentiate these from one another. So let's start with business analytics. Tools to explore past data to gain insight into future business decisions. So when we look at business analytics, we are looking at having historical data as a business organization or entity and try to look at what predictions we can make based on the existing data that we have. So we analyze this data and find out whether we can look into the future, make decisions with this data that we have based on our analysis. So that is the focus. The focus is looking at past data and future decisions. So for instance, if you take any sector, for instance, the telecom sector or the banking sector, you would look at a typical company, business like, let's say, MTN, and MTN probably might want to roll out a particular product, and they need to make a decision on rolling out this product. They can decide to look at the past data they have on customers, their preferences, the type of products they have, whether certain age groups prefer certain particular products or not, and based on this analysis they might decide to roll out this product or not. So let's look at BI. BI or business intelligence, tools and techniques to turn data into meaningful information. So when you look at BI, we are looking at whatever data you have. It can be quite difficult trying to translate this data into information. And as we define information as processed data, the data needs some form of processing to make meaning out of it. So tools and techniques that we would use to turn this data into information, meaningful information, we would then say we are looking at business intelligence. Big data are data sets that are so large or complex that traditional data processing applications are inadequate. So, if you may recall, where we looked at big data, we looked at certain attributes of big data, and one of them is volume. Okay, so in terms of volume, we can look at very huge volumes of data. Okay, we can look at velocity as part of big data, where you look at the speed at which this data is processed or it is churned out. And we looked at how social media churns out a lot of information and quickly. Okay, then we can look at the complexity of the data. So it can be so complex that it consists of structured and unstructured data, multimedia, different types of data, and its complexity also makes it big data. So in such data, we cannot use traditional methods or tools of analysis to analyze that kind of data. So we will call that big data. And what is data mining? Tools for discovering patterns in large data sets. So if you want to discover patterns in, for instance, big data, you do data mining. So if we look at the keywords, for business analytics, we look at past data, then future decisions. Then for BI, we have to look at data and a meaningful information. With big data, it's quite straightforward. So isolating big data from the rest of these concepts is not difficult. And data mining, we look at patterns. The keywords are patterns and then large data. Okay. So a recommended textbook is Making the Most of Big Data, Kandasamy and Benson, 2013. Okay. You can go to bookboon.com to try and get a free copy. I've not tried it myself though, but you can give it a try and see if you get access to do that. Okay, so why do businesses need support for decision making? We can look at uncertain economics, rapidly changing environments, global competition, and demanding customers. So we know very well that as a business, you operate in an economy, right? So we can look at the macro economy and the micro economy, and we know very well that, for instance, the forex regime, and in terms of foreign exchange regime, can have an impact on your business. So, for instance, if we cannot actually predict how our currency will fare internationally, anything can happen. If you have a sudden, for instance, hike in the price of the dollar, it has an effect on your business, because you are likely to have dealings that would require the use of dollars, for instance, and you can look at supply and demand factors that come to play in the forex regime. So in such instances, you would need to probably make some decisions, especially if it's in the finance sector, and you might want to fall on um, tools that would support your decision making. And yes, of course, we cannot say that we live in a static environment. Our environment keeps changing day in, day out, and some uncertainties may come to play. For instance, the issue of pandemics, and all of you can relate to pandemics because of the COVID situation, etc. So in some of the, depending on the sector that you are in, you might want to take certain critical decisions to to help you salvage your business. And you bear with me that companies have had to resort to um, redundancy in terms of laying off workers, retrenchments, etc. And some of these things will require some very critical analysis of the business so that you would want to make the best decision. It's a global competition. Yes, we cannot run away from competition, and if you are competing with, for instance, companies that are probably supplying similar goods or providing similar services, but are global, you would want to also be very critical in taking decisions based on competitive forces. And customers also can be demanding, and based on competition, you would have to make sure you satisfy demanding customers because they are essentially your business, and where they see alternatives and they think that the alternatives are better, they would most likely fall on your competitors because of perceived better service or lower prices, etc. So these are some of the reasons why you would want to look at having decision support systems that would help you take the best decisions to salvage your business. Taking advantage of information acquired by companies is a critical success factor, and as I've explained earlier, success of your business depends on the kind of decisions that you take, especially as a manager. Okay, so we can look at some characteristics of data for good decision making. So it is not just any data that you'd want to use if you want good decision making. So for better quality data, we can look at some key characteristics that this data must possess. We look at accuracy, validity, reliability, timeliness, relevance, and completeness. So it is a collection of characteristics which we need to ensure that this data has. So we do not want accuracy but no timeliness. We don't want validity but no reliability, etc., etc. So for instance, when we look at accuracy of data, so we say it should be accurate enough for intended purposes, balanced with use, cost, effort, timeliness, capture close to point of activity, make accuracy compromises clear, right? So we have to look at issues of whether we have value for money. For instance, if we are looking at data that we have to acquire, where there are issues of costs, etc. Okay, and we also want to make sure that it is fit for purpose. Okay, it is data that we actually will find useful, and where there are certain compromises with accuracy, it should be clear in that if there is a margin of error, it must be clear, and then the source of that should also be clear and understandable. In terms of validity, we have compliance with requirements. Okay, we are looking at whether this data will be valid, and for instance, if it has to do with whether there are clear definitions of what this data is, it should be clear. Okay, there must be consistency over time, and then consistency with others. So for instance, if you have various sets of data that you are looking at, that data must, over time, there must be consistency, and then if there are different data sets, that consistency also must exist. If there are variables in one data set and similar variables in another data set, there must be consistency in these variables, even though they exist in different data sets. Reliability, collection processes should be consistent over time for multiple collection points between collection systems. So in terms of reliability, you must, if there are certain skills that you are using, especially to acquire this data, if there are certain measurements that you are applying, it must be consistent. So if you are probably pulling that data from a particular source, the way you pull this data must be consistent for each pool, and it must not be a one way of pulling data from this point, and then at another point it's a different way of pulling data. That reliability must exist. Timeliness as well, you should capture quickly over events, and it's just a matter of speed. Relevance, it must be relevant to the intended purpose. So for instance, we should look at periodic review of requirements, quality assurance and feedback processes, and if it's going to be used for other purposes, care must be taken in the sense that although it can be of use for one purpose, it does not necessarily mean that it will be of use for other purposes. Completeness, monitor quality to match data needs. We have to look at missing data, invalid data, and then incomplete data, and these should be carefully managed. Okay. The shortfall between gathering information and using it for decision making can be referred to as the information gap. So what you are looking at is that there's data, there are probably huge data sets sitting there. The data has been actually analyzed using BI to make some meaning out of it. So probably information. Then that has been done, but this information is not being used for decision making. So it's like there's a gap. Data, information, and then decision making. All right. So what are the likely reasons why, or the issues? So for instance, you can have firms having inadequate data warehouses. So if the data is sitting there, and we looked at I think we've looked at the framework of the data houses. I'm sure we looked at the framework. We might not have gone deep into it, but you would look at the framework where you have several sources of data, and then you are looking at ETL, that's extract, transform, load. Okay, so if the data is sitting there and that particular ETL operations are not going on, that would then move the data from their sources, transform or clean them, and load them onto a data warehouse, and then to data marts, then so that at the level of the data marts, the specific managers will have access to these data that has been analyzed and all that, and models have been run on them, and they have come out in a very clean state for managers to use, but then it's not being used for decision making. Okay, so business analysts spend 2 days, for instance, a week gathering and formatting data instead of performing analysis. So in that sense, the data is being gathered and formatted, but then no analysis is being run on them for decision making. So BI seeks to bridge the gap, information gap, and as we mentioned in the earlier slide, where BI looks at how do we get information out of this data, right? So that whatever tools or techniques we have to transform this data into information. So at the end of the day, BI seeks to bridge this information gap. Data mining. So we would need to look at certain keywords that pertain to data mining. We can say it's interdisciplinary. It is computational. We look at patterns. We look at artificial intelligence, machine learning, statistics, and database systems. So data mining is an interdisciplinary subfield of computer science. It is the computational process of discovering patterns in large data sets involving methods at the intersection of AI, machine learning, statistics, and database systems. So in essence, it is an intersection. It means we have AI, machine learning, statistics, database systems intersecting to analyze data sets, and it's a computational analysis. That is why it's a subfield of of computer science. So it combines all these in order to be able to discover patterns in large data sets, basically. So you can have huge data or big data, and use all these tools to discover patterns in that data. And outputs is new information. And as I mentioned earlier, I use statistical methods. And another very interesting thing, finds hidden features of the data that were not yet known. Okay. So once again, talking about BI, we can look at the process and then the product. We've mentioned want to turn data into meaningful information, and it involves a process and then an outcome or product. Okay, the process methods used by the organization to turn data into knowledge, and the product is information that allows businesses to make decisions. So how do we apply BI, and in which environments and in which scenarios do we apply BI? So we can say one, in customer analytics, okay, human capital productivity analysis, business productivity analysis, sales channel analytics, supply chain analytics, and then behavior analytics. So in essence, we can look at analyzing the customer base entirely to look at trends and then categories, etc. Okay, then you can look at your staff. You can look at, do a productivity analysis of your staff, and find out who is the most productive, etc. You can look at the business productivity itself and which areas of the business can you say are most productive, especially if you have various business segments where they focus on different markets. Sales channel analytics, you look at the sales channels that you have and which of the sales channels are most productive or most efficient, etc. So for instance, where you have your business is highly reliant on sales, okay, you want to do that. So for let's say a typical example is where you have you are dealing with what we call FMCGs, or fast moving consumer goods. You want to identify the various sales channels, okay. Also, even in the banking sector, you can have different sales channels. You can have an outbound team and then an inbound team. So for instance, an inbound team can be a call center where you have staff who are on phone at all times, and they are calling, trying to create new business or get repeat business. Okay, then you could, the outbound team can be field salespeople who go out to meet customers and try to bring new business. Then also you can look at probably sales managers who also focus on different particular market segments. So you can look at all these and then do analysis of all these sales channels. And then supply chain, looking at procurement issues and how effective your supply chain mechanisms are. And also behavior analytics, and behavior analytics can also be tied to customer analytics in a way, because consumer behavior is the most relevant kind of behavior you also want to look at. But then it might not, it might go beyond that in so many ways, because behavior can be of different dimensions. Okay. So what is business intelligence? As discussed earlier, we can say BI is collecting and refining information from many sources, both internal and external, analyzing and presenting the information in useful ways, for example, dashboards and visualization. So the idea is that you want to make the output as simple as possible, and that managers don't really need to see the complexities behind the outputs. So for instance, you might use complex algorithms, etc., to um, generate some output for managers, but you must make it simple. And one of the ways is to use dashboards, digital dashboards, etc., so that people can make better decisions, of course, that help build and retain competitive advantage. So for instance, this can represent a marketing dashboard where at a glance the viewer can see the number of followers for each social media platform, and then can also see the number of leads for the month, ready sales, new customers per month, and the new revenue for the month. So at a glance, the user can just have all this information on the dashboard, and it would help in decision making. And you can have simple charts that would also show trends and other things. So in terms of BI initiatives, some reports or investigations into results of BI initiatives show certain, should I say, challenges or issues. So for instance, Z Associates report that 70% of senior executives report that analytics will be important for competitive advantage, but only 2% feel that they've achieved competitive advantage. So what it means is that you can have the BI initiative in place. Senior executives would trust that this would help in gaining competitive advantage, but the truth is, do we feel, or do we agree, or are we convinced that we are actually achieving this competitive advantage? So if 2% feel that the business entity has actually achieved competitive advantage, then it raises questions as to what the BI investments actually achieving. Okay. And then Goodwin also states that 70 to 80% of BI projects fail because of poor communication and not understanding what to ask. So it is important that for BI projects to be successful, there must be good communication and an understanding of, for instance, senior managers must understand the whole setup, and must also be able to demand specific things from database administrators or programmers, etc., so that they can actually get the output that they actually require to be able to take good decisions. So LAPU 2007 also states that 60 to 70% of BI projects fail because of technology, culture, and lack of infrastructure. So technology must be right. That culture, that organizational culture must exist that would encourage the use of BI. And then there must also be enough infrastructure to support the BI initiative. Evolution of BI. As we discussed in the previous lectures, about evolution of DSS and analytics. We can also look at a graph that shows how BI has evolved. And you can see on this axis competitive advantage. You can see on this axis analytics maturity. So it means this is 0 and it increases this way and also increases this way. So it starts with raw data, clean data, standard reports, ad hoc reports, and OLAP, generic predictive analytics, predictive modeling, and optimization. So as the analytics maturity goes up, as it evolves, then there is a corresponding increase in competitive advantage. So at this stage, you can see what happened. The questions that these technologies try to answer is what happened. Then as it evolves upwards, why did it happen? And then what will happen, and what is the best that could happen. All right, so it just tells you that as BI evolves and the analytics matures, there is a corresponding increase in competitive advantage. So we can continue and look at user evolution against vendor evolution. Okay, so starting from the 1990s, 2000, 2007, 2010 and onwards, you can have if we look at that intersection, and as both of these increases, you would see client server, web services, mobile, and then cloud. Now, as both the user and the vendor evolves, we can look at from data warehousing to analytics, and the evolution is from data warehousing to business intelligence, performance management, and analytics. So, and each has its focus and the core, for instance, deliverables that accompany each, should I say, era. So we can look at getting the data, that's data warehousing, using the data for BI, optimize performance, and that for performance management, and analytics to drive processes. Okay, so performance management is key, and it enforces that performance culture in the organization, and actually tries to make the organization more profitable. Okay, and in doing that, we also want to make sure that our core business processes are, should I say, sorted out. And as I mentioned earlier, we can say that a business organization consists of its business processes, basically. So when you drive the business processes, you drive them, you make them, you fine-tune them, you do business process re-engineering, then you are trying to make the entity much more efficient and achieving success in terms of competitive advantage and your bottom line of profits and so on. Okay, so we can look at the data warehouse. We try to make it as simple as possible, and we've already discussed the data warehouse framework in in the other course, but we can also look at this schema or diagram. Okay. So what is a data warehouse? A collection of data from multiple sources, both internal and external. Summary, historical operations, data cleaning before use, stored independently from operational data, and broken down into data marks for you. So we can look at these are the sources, and as we've mentioned, the data warehouse takes its source from different places. So for instance, from your ERP or your enterprise resource software, the marketing, for instance, if the marketing department, they have a system where they used to manage their operations, and it's a software application. Definitely it will have a data management system, and you can have data sitting in there, and HR too has, and then the sales too has its own software applications and holding sales data, etc. So ETL operations extract, transform, load. Okay, so the data warehouse extracts data from these numerous sources, and mind you, the data from these sources might not have the same format. So for instance, data from sales will have a format that is different from HR and from marketing and from the ERP. So there's some form of transformation of this data, especially to make sure that the formats are uniform. Okay, so this data is loaded into the data warehouse, where there are programs in here that uh, process this data. There's analytics, there's BI, there's a lot of processes going on in here, and these generates data for separate data marts, which are used by managers of different levels. So for instance, you could have a data mart for the chief finance officer, could have a data mart for the chief marketing officer, and the chief HR officer or the head of HR. So in terms of data mining, we can look at 5 tasks of data mining. And from the first slide, if we can recall, we try to identify certain keywords with each of the concepts. And for data mining, we were looking at patterns. Okay, so the idea is that we look at data, and then we try to find patterns in the data. Okay, so these are 5 tasks that the data mining should perform. So classification, that is categorizing data into actionable groups. Okay, so for example, we can have, if we have data of our customer base, we can categorize customer base in terms of loan applicants. Estimation, response rates, probabilities of responses. Prediction, predicting customer behavior. Affinity grouping, what items or services are customers likely to purchase together? So we are looking at our services and the different kind of services, and which customers are likely to have affinity for each particular service. Description, finding interesting patterns. As I mentioned, data mining should give us the output of the data mining should give us patterns that can make sense to us in terms of our decision making, and also understanding the way the business is going, or how the business is running. Okay, so what are the data mining techniques? You can look at one, market basket analysis, cluster analysis, decision trees and rule induction, and then neural networks. So what is market basket analysis? Finding patterns or sequences in the way that people purchase products and services. So Walmart, as we know, it's a huge retail company, and they have lots of branches across the world. So a typical retail um, business would want to look at how to get people to buy more. So you do a market basket analysis. As the name suggests, it's a basket. So it means that it is not just one item, but you are looking at how to get people to buy more. And in marketing, it's a cross selling strategy. So um, it's obvious that people who buy gin also buy tonic, right? Non-obvious, men who bought diapers would also purchase beer. So it means that you are looking at certain patterns. Okay, so the suggestion is that um, these are products that go hand in hand. Okay, um, and if you study um, somebody, a man who is buying diapers, it's likely it's not the type of person who buy beer, basically. So um, market basket analysis tries to look at how to increase a customer's basket, if I should put it that way, thereby increasing sales. So cluster analysis is grouping data into like clusters based on specific attributes. For example, a crime map cluster or crime map clusters to better deploy police, where to build a cellular tower, outbreaks of Zika virus. So the idea is, if we want to look at clusters in terms of um, crime, we would want to look at probably um, a place where if we have data, we can actually say that, okay, so this area is known to be a crime prone area. So you want to, in deploying police personnel, you want to be strategic. So you would want to focus on the crime prone areas so that your deployment will be much more strategic. And where to build a cellular tower, you want to build a cellular tower where you would have customers who would actually use the service. So you want to find clusters where you know that, okay, I am likely to get a lot of customers using the service. You don't just plant a tower anywhere, and it's expensive maintaining a tower. So for instance, if you have one cell site, if you ask somebody from Vodafone who is into in probably the property department, would tell you how expensive it is to even just mount one cell site. So that being an investment, you would want to make sure that you get returns on investment. So you look at clusters where you are likely to get customers who would use the service. So in summary, we've explained BI analytics, data maths, and big data. We've defined the characteristics of data for good decision making. We've described data mining and explained and gave examples of market basket and cluster analysis. Thank you very much.